Okay, I wanted to do a quick video about reversing the order of integration on a double integral. Okay, so let's write that at the top. Reversing the order of integration. All right, I'm going to take an example here. Write the appropriate integral. With the order of integration reversed. Scribble, scribble. Here it is. Going from 0 to 2. Okay. 0 to 4 minus x squared. I'm integrating some function of x and y. dy dx. Okay, so I'm going to give you guys a question of this kind on the exam. So you guys need to be ready for questions of this kind. Okay, now let's look at the inner integral. Okay, the one you're actually working on first. That would be this guy, right? Okay, now these limits of integration are what? Y values, right? Because we're integrating with respect to y first. So y goes from 0 to what? 4 minus x squared. And then in the outer integral here, the second one that we actually compute, these are what? We're integrating with respect to x, right? Okay, because we're doing all this on the inside first. We would get a function of x. Then we would integrate that with respect to x. So x goes from 0 to 2. Now, when I ask you a question of this kind, you want to extract this bit of information just like this. And what you guys want to do is draw the appropriate region corresponding to these limits. That's in essence, that's half the problem here. Okay, so let's go ahead and do that. So suppose I have the xy plane here, and I'm going to graph these. Let's see, I will go with x equals 0. That's just the y-axis. Y equals 0, that's the x-axis. X equals 2, that would be this vertical line, x equals 2. And then the parabola, y equals 4 minus x squared. This looks kind of bad, but it would be a parabola going down like this, right? Okay. Let's find the points of intersection here. Okay. Now you guys see here, here's my boundaries. Okay. And then what? This thing. So what I'm actually integrating over is this. Okay? This is my R. Alright. So let's see that. Let's see if that doesn't make sense here. Here we're integrating in the y direction first. Just do a double check here. We're integrating in the y direction first. So y would go from what? 0 to 4 minus x squared, right? X is varying. X, however, will go what, from 0 to 2. All right, so that makes sense here. Now, what I'm going to do is on the next page, I'm going to redraw this with a better picture. Okay, so the scale looks a little bit better. And then we'll reverse the order of integration here. Okay. All right. Let's draw this a little bit better this time. This parabola, it's frowning here. It's 4 minus x squared. Imagine this now. Here's my xy axis. Okay. This is actually what? 0, 4. This is the origin. This is what? 2, 0. Okay. Now, I'm integrating. I want to integrate in the x direction first this time, right? Because I was integrating in the y direction first previously. So I want to integrate in the x direction. So my little pickets, my cuts here. I imagine I've taken a value of y. And then what? I'm integrating in the x direction first here. So I've got these little partitions. Okay. So I'm going to be looking at this. Looks like I can get away with just a single integral here. Okay, my integrand is f of xy. Don't actually know what that is. We're integrating in the x direction first, then we'll be integrating in the y direction. Okay, now where is x going from? X is going from what? 0 to what? Now this is going to be a function of y, right? Because I want this inner integral is all going to end up being a function of y, which I'm going to integrate in the end with respect to y. Okay, so let's see, we actually had this was what? Y equals 4 minus x squared. Okay, now I need x in terms of y. Now solving that, you guys see that x is going to be what? The positive square root of 4 minus y. Doing a little bit of algebra in our head. We want the positive value, right? We're only getting positive values of x here. So this is going to be the upper x value, a function of y, right? At least one of these has to be what? Variable, otherwise we're integrating over a rectangle in Cartesian coordinates, which we're certainly not. Okay? Now these have to be what? Constants here at the end, otherwise you wouldn't end up with a number. Okay, this has got to be a number. That is not hashtag, that's number. Okay? What are the y values? Where does y go from and to? From 0 to 4. So our answer is this. Okay? There's the answer to that problem. Okay? All right, let's start another problem here. Here I've got another example. I'm integrating from 1 to 10, 0 to the natural logarithm of y, some integrand f of xy, integrating with respect to x first, and then y. Now we want to reverse the order of integration. How are we going to do that? Well, we need to, what? Let's write it this time. Let's go construct the region over which we are integrating. Construct the region. Can you read that? Well, unfortunately, I said it. All right, let's go ahead and look at this. Now, on the inner integral, we're going what? X equals 0 to x equals y. Okay, right here. Here, y is going from 1 to 10. We need to think about geometrically what that would represent. Okay, so let's go ahead and draw this. Okay, x equals 0, as always. X equals 0, that's the y-axis, okay? Y equals 1, y equals 10. Those are horizontal lines, aren't they? All right, I'm a bit off on my scale, but that's okay. I don't want to smash this all in here. Let's say this is y equals 10. Let's say this is y equals 1 here. Okay, that's the x-axis, that's the y-axis. Get those labeled, okay? And then I've got what? X is equal to the natural logarithm of y. I'm going to jump in here. Everybody knows that the natural logarithm of function is 1 to 1. It has an inverse, right? This is equivalent to saying what? Y equals e to the x. Yes, the exponential function and the natural logarithm function are inverse functions, right? They're inverses of each other. All right. What does this look like, y equals e to the x? Well, I hope you remember. It looks like this. It's got a horizontal asymptote being the x-axis. Okay? When x is 0, y is equal to what? E to the 0 is 1. It goes right through here. Okay. And then this grows up exponentially. Like that. Remember how that curve looks? Now, again, this stuff doesn't have to be perfect or anything like that. So it looks like our region of integration is this, let me maybe write it here instead. x equals 0. And this looks kind of like a sort of a pseudo triangular figure here. Okay, this is our r. There it is. All right. Let's actually label this curve as y equals e to the x. Now, let's see, what we're supposed to do here? Oh, we need to integrate in the y direction first, this way. So we're going to be getting up and down. Okay, so I imagine that I'm going to be integrating like this. Now, let's go ahead and label these points here. What do we have here? We've got 0, 1. What's this right here? Well, let's see. The y value is 10. The natural logarithm of 10 would have to be the x coordinate, wouldn't it? Okay. And then this over here, well, the x coordinate is 0. The y coordinate is 10. Now, what I'm imagining doing then, right, taking a particular value of x and integrating in the y direction here. Where is y going from and to? Well, let's see. Y would be going from e to the x up to what? 10. It's flat on top there, isn't it? F of xy, there's our integrand, don't forget that. Okay? That's where we've integrated out the y. Okay? Now we're going to integrate in the x direction. If I take this region and project it down onto the x-axis, do you see I get everything from what? 0 to the natural logarithm of 10. Okay? Maybe I could do this. I could call this I. Okay? This is also I. Okay? So if I have what? A continuous function or an integrable function, right? And I integrate it this way or I integrate it this way, I'm always going to get the same answer. Very cool. Alrighty. I hope that makes sense to you. There it is. Let's do one last example of reversing the order of integration. This time I'm actually going to integrate because I've given you a particular function, integrand that is. Okay, the first thing I would like to mention here, if you guys take a look at this integral, this inner integral here, you could try to find an antiderivative for that. You will fail. That is a transcendental integral. This is supposed to be a dy, sorry. Okay, that's a transcendental integral. You can't integrate e to the minus y squared dy, find an antiderivative in closed form. You would have to resort to something like a series expansion and integrate term by term. You could do it that way. That would be really long and arduous, and the answer you got in the end would probably be unrecognizable. Let's go ahead and try something else. We're going to reverse the order of integration on this thing and see if we can't work it this way. Okay, what are we going to do? What's the first thing you do? Well, you're going to, construct the region over which you're integrating. So I've got what? I'm integrating with respect to y first. That's the inner integral. So I've got what? The limits are looking like this. Y equals x. We know that we have that line in our head here. And then we've got what? A nice flat line. Y equals 2. That's cool. The outer limits, the last ones we're going to do, are what? X equals 0 to x equals 2. So keep those in mind there. Okay? We need to graph that. Okay, what does that look like? What is the region over which I am integrating? Okay. Let's go ahead. Didn't have to be a perfect picture. We've got y equals x. We know what that looks like. It's a nice easy line. Take some easy examples. We've got x equals 0. That would just be the y-axis. We've got x equals 2. That's another vertical line. 6 equals 2. Okay. We've got y equals 2. Okay. Y equals 2. What does that look like? Well, I claim it goes right through there where those intersect here. This is y equals 2. Okay. You guys see that point of intersection is actually 2, 2. Okay, now you got to be careful. Am I integrating over this triangle or that one? The answer is actually this one. The upper limit here in your integral, it goes from what? This line up to 2. The upper limit is actually the 2. So here's what you've been doing. Originally you were integrating what? In the y direction, so you went this way, like that. And then you're integrating what? This way. Okay. Suppose I could label these points a little better here. Okay. So everybody understand, this is the triangle over which we are integrating. Okay, what would this be? 0, 2. Okay, now I need to integrate with respect to what? The x first. Okay, so I'm going to be looking at this. Okay, fixed value y, integrating in the y direction. What's it look like? Okay, here comes my double integral, so this is going to be I. Okay. E to the minus y squared dx and then dy. Okay. Well, where's x going from and to? It's going from 0 out to this line. It's always starting at 0, but it's ending up at that line. That is going to be a function of y, right? Okay. This whole thing is going to give me what? A function of y in the end, which I'll integrate with respect to y. Where's y going from and to? Well, if you project this triangle onto the y-axis, you're going from 0 to 2. Okay? Now, this is not my final answer. You guys know I like to box in your final answer. But this is obviously an important milestone. Now, let's keep going here. Remember, we're going to do what we were calling a partial integration here. So this is actually going to be easy to evaluate now. Yeah, this one was transcendental. I got stuck up here. But this is I'm going to show you, it's going to be easy right here. Okay? Let's do it. No. Sorry, I had to take a little break there. The cat was about to come leaping up here and get in front of the document cam, which is something she loves to do. Okay, let's go ahead and work out this inner integral first. I'm integrating with respect to x, right? So I'm treating what? Y like a constant. So do you guys see I could effectively bring that outside of the integral? The e to the minus y squared, that is. So I'm going to just do this. I'm integrating dx, right? Which is just x. Going from 0 to y would be e to the minus y squared factor by minus 0. And don't forget your dy here. Cool. Okay? So this is the integral from 0 to 2, e to the minus y squared y dy. Now, can you think of a technique that you might use to integrate this? Sure. You're probably thinking about this. U equals, how about minus y squared? That would mean differential changes in u are negative 2y times differential changes in y. So that means 2y dy is actually negative du. Okay, so what is my integral looking like now? Okay. Let's see, e to the minus y squared is now e to the u. Y dy is actually what? Negative 1/2 du. I'll take that negative half out front here. Let's see, what are the limits of integration? Now remember, here they involve y's. Here they're actually what? U's. When y is 0, we get what? 0 here. When y is 2, we get negative 4. Okay? So we've got negative 1/2. Okay, I'll bring out front. Now wait a minute. Can you integrate in your head e to the u du? I hope you can. That's e to the u. Don't have to worry about adding a constant on the end of that. And we're going from what? 0 to negative 4. Let's stick that in there. Negative 1/2 is a common factor between the two terms. So I'll keep that on the outside. E to the minus 4 minus e to the 0. e to the 0 is 1. I'll change the order then, because with this negative sign, so that's 1 minus 1 over e to the 4th, all divided by 2. Now that strikes me as quite ugly, so what I'm going to do is rewrite the numerator as e to the 4th over itself minus 1 of those over that, and we get this in the end. Alrighty. Oh, a way you can check some of your calculations here, if you've done this online ever, is to go ahead and look at Wolfram Alpha. It will do some of these double integrals for us. Okay, but there it is.